Good morning. How's TechED going so far? Good. Awesome? Okay, good. Hey, my name is Mike Brimmer, product manager for Studio 5000. Welcome today to designing smart machines for the connected enterprise. You know, we live in a day and age where consumer demands are ever increasing. New products are constantly being introduced, and personalization is everywhere. From seasonal to regional to scalable packaging, companies are continually looking for ways to ensure that consumers are offered the right products at the right time. But how do we keep up with these ever-changing demands? How do we adapt and make these adjustments in real time? Well, the connected enterprise can help. By linking together smart machines with enterprise-level business systems, we can make real-time adjustments based off of contextualized information. This can help us to achieve a faster time to market and a lower total cost of ownership. So when we're designing for these smart machines, we might need to leave behind some of our older philosophies, such as the set it and forget it, because we need these new systems to be adaptable, flexible, and information-enabled. You know, as developers of automated systems and equipment, you know how short the development process can be, but you also know how critical it is. And you know if we don't adapt for flexibility and plan for that, we might just be redesigning sooner than we thought. Yeah, the development process, we get it. It can be pretty complex, even overwhelming at times. I mean, you've got serial stages when you're waiting for one thing to occur before the next, and iteration stages where we're going back and forth and back and forth. It can be time-consuming. And what about things like system configuration, content management, and just multiple people all trying to work together at the same time? Well, our team knew if we were going to help you meet these challenges, we needed to thoroughly understand this process. So we mapped it out. We sequestered some of our best and brightest, and then we reached out to you, the users. We documented your many and varying steps, and what we realized was that while some things did differ a bit, they still all follow the same general pattern. So let's take a minute now and listen to some of these challenges from users like you.
My name is Gina, and I'm a project engineer for a system integrator. I'm responsible for getting the project started. I need an easy way to set up and configure our automation systems.
Hi, my name is Ben. I'm a controls engineering lead. Managing code takes my team a lot of time. I need some advice on the best way to manage and reuse that content.
Hey everyone, I'm Miguel. My team has several needs as we design the system. Scalability, modular design, and collaboration. Please, tell me you can help.
I'm Julian. My company is working on a new machine design, and we need help designing a world-class operator interface.
You know, those are some pretty common user challenges. In fact, it looks like they impact efficiencies in several areas of the process here. So let's give our users a chance to ask some more specific questions. But first, I'd like to introduce a few core members of the Studio 5000 team. These guys are recognized subject matter experts in their respective areas of focus. And so today we have Tony Carrera for system design, Lorenzo Majewski for library, Chris Como for control design, and finally Mark Hobbs for view design. So without further ado, let's go ahead and hear that first question.
Our office is celebrating. We just won a huge project. We won the bid because the Rockwell automation system will give our customer the ability to connect their plant floor to the enterprise. That's incredibly valuable to them. This is a pretty big project with multiple controllers and HMIs. Is there an easy way to set up and configure the system? It would be great if we could do this all from one place to keep it simple.
Good morning, everyone. My name's Tony Carrera, and I'll be answering Gina's question. Just like Gina, you are an engineer that's been assigned lead responsibilities on a new engineering project. As part of one of your many new responsibilities, you need to set up a base configuration or a system framework for the team to get working on. You have been handed a diagram or two, as well as a hardware list. This is the information you're going to start with at a minimum to create that system framework. The system framework is made up of the 3 layers that we're all used to: control, supervisory, and the network layer. These 3 layers have configuration settings, an initial project, as well as in some cases, project content. So we need a tool to help the team build up this framework. Over the last few years, we've talked to you about the strategy of Studio 5000. The core of that strategy is increasing automation productivity. A key foundation of this strategy is how to build up your system using our products in the most productive fashion. Just like everyone that heard that message, I pictured a system interface that would help me streamline automation tasks. In Studio 5000 Architect, we are introducing this environment to have a tool that will grow into something that you'd use for all life cycle stages of a system. But initially, we're going to start out and just have this tool help you for the first initial test, get things set up and people working. This week, we are adding to the list of what Studio 5000 delivers. As you go to this common launcher, you'll pick New Project. From New Project, you'll now have multiple project types. The project types you could pick from are Architect, FactoryTalk View Studio, Logix Designer, and View Designer. We're going to go ahead and pick Architect, pick the blank project, and just stick with our naming conventions, we'll call this System 5000. So we'll launch this tool, and as you see the interface come up, you'll immediately notice the middle layout area. This layout is meant to help you build up your system graphically. All the building blocks for this layout are over on the right-hand side. So let's go ahead and build up our control layer. First, we're going to start with 4 ControlLogix chassis. In each chassis, we'll add a controller, an Ethernet module, and I/O modules. For each one of these modules, you can do a base level configuration. Now we'll go ahead and add the supervisory layer. In this case, we're going to have a distributed HMI and 2 machine-level HMI devices. So we'll add 4 servers to the layout. Each server will have 3 logical servers. The 3 logical servers are FactoryTalk View SE, RS Links Enterprise, FactoryTalk Alarms and Events. Our 2 machine-level HMIs are PanoView Plus 7. And so as we have between the machine level and the distributed, we now have our supervisory layer. Let's tie it together with a network layer. So we're going to pick a Stratix 5700 20-port switch to tie everything together. This is Gina's configuration. So as we've tied everything into the Stratix switch, you could just see the opportunities from this layout, a system perspective of what you can work on around streamlining these tasks. 2 examples of these opportunities are setting up runtime communications. So now you can connect your RS Links Enterprise data server to your ControlLogix to set up your shortcuts. So what you would do is you take your Ethernet module and your controller from the rack and drag it onto your data server. This sets up the path between the 2, as well as designate your targeted shortcut. We could also set up interprocessor communications. So we could go between 2 chassis and set up communications for produce consume tags. So again, these are just 2 examples of what you can do now with the system layout. As we've built up this configuration, you'll notice on the left-hand side a Project Explorer. As everything was added to the layout, slowly your project structures started being put into place. Taking a closer look, you'll see we have our distributed HMI, areas and servers underneath that. We have a project structure for our 4 ControlLogix processors. And then we have FactoryTalk View ME for each one of our PanoView Plus 7s at the bottom. One single unified Project Explorer for your system. So our Studio 5000 Architect project's really coming together. Now we need to take this layout, this architecture, and build project files. So what you will do is, from the layout, you could select to do the commit process The commit process takes all the associated projects and actually makes project files for FactoryTalk View Studio, as well as an ACD file for Logix Designer. You can then, once you do the first commit process, you can now launch from this layout into the individual designers by either selecting from your Project Explorer or right-clicking on a device and say, Open in Designer. It'll take you right into FactoryTalk View or Logix Designer with that project open. From that designer, you can now make changes. The changes that you make in either FactoryTalk View or Logix Designer can then be synchronized back into the Studio 5000 Architect project to keep everything updated. So the three things that you could really do, as an example, is number one, create your system layout and use the commit process to create your project files. Number two, once you've done that commit, you can now launch into the individual designers from this layout. And number three, you can then use the synchronize process to update your architect project. Commit, launch, synchronize. This is coming out later this summer as part of V27's release. I think this is a solid step forward into increasing automation productivity. I think we're going to move on to our next question and see what other help we can provide.
As a controls engineering lead, it's my job to make sure our projects run smoothly. Being efficient is the best way to stay on time and on budget and end up with a decent profit. We continue to build up some good libraries of code, but we struggle with how to best manage and reuse them. Any thoughts?
Hello, my name is Lorenzo Majewski. Rockwell Automation has created a new design tool that will allow you to leverage your reusable content, helping you with increased deployment efficiency, accuracy, and overall cost savings. This tool allows you to bulk configure and bulk build your project content. It's able to do this by allowing you to leverage your reusable content and turn those into modular objects. All modular objects then are stored in libraries. What's unique with our approach is that modular objects stored with an application code manager are embedded with configuration parameters. Configuration parameters that allow you to specify all the pertinent information on how that object is to be used in a project versus programming it. For example, using configuration parameters, you could have a motor control object that not only allows you to specify a unique name and description for use in a particular project, but in addition, the motor control object could be designed to allow the user to specify, is it a single, reversing, two-speed, or hand-operated motor control. Additional parameters can be used to indicate if electronic overload is needed or not. If the user selects yes, additional parameters then could be presented to the user to allow them to specify which kind, an E1, E3, or an E300. Another example is an analog input channel object that uses configuration parameters to allow the user to specify engineering units, minimums, maximums, or any host of other features or attributes such as fail high, fail low, deadband, filter, etc. When an engineer is working on a project, they simply select their modular object and configure that modular object for the project they're working on. They don't need to know about all the underlying code that's required for that particular project. Application Code Manager is built leveraging a Microsoft SQL database. As the engineer selects modular objects out of the library and configures those objects for a particular project, all this information is being stored in the database. Having this information in a database provides for centralized access. Any engineer that has access or in the office can easily access the database for project contribution. Another benefit of having this information in a database is that if multiples of the same object are required, the user could simply export that configuration to Excel, add additional configuration as required using Excel, save that file, and then import that back into Application Code Manager, basically updating the database. Once all the configuration is complete, you can go ahead and do your bulk generation of your project. When you initiate a bulk build, ACM, or Application Code Manager, will start to assemble all the objects out of the library and transform those objects based upon the user-supplied configuration, transforming names, descriptions, tag values. It will also even remove unnecessary code that's not needed in the project per its configuration. Having this ability to remove unnecessary code provides for easier readability and future maintenance. Once the build is complete, you could simply open up the project files using Logix Designer, add additional configuration if required, or simply download to the controller for testing and verification purposes. The goal of the tool is actually to build upwards of 100% of the Logix content. In addition to building Logix content, though, it will also produce view, historian, as well as FactoryTalk alarms and events. You know, our vision is that whether you're an SI, OEM, or even an end user that deals with batch, process, safety, motion, discrete applications, will find significant value in using this tool. And this tool will become integral, part of your workflows when you're either creating or updating Rockwell Automation content. So with that, I thank you, and I think we've got another customer, Miguel, who's got some other questions.
Yeah, I sure do. I work for a company that makes a lot of different machines. Our smaller machines aren't quite as complex as our elite line, and there's a mix of safety, motion, and process. So we need a solution that can help us deliver all of this. But I can't afford to train my staff on different control systems. Any suggestions?
Well, Miguel, that's a common trend we see today. As devices become smarter and create more and more information, and then use that information to control more things, there needs to be a solid foundation that we build that upon. Now, your question really contains two parts, but there's a common answer to both. The first is that your applications range in different sizes. The second is that you've got varying degrees of complexity. When you look at our offering of integrated architecture, you'll see that scalability to match the applications you're faced with. Everything from a compact Logix controller, control Logix, guard Logix, even on-machine controllers. That extends into our I/O platforms, drives, motion control products, and operator interfaces, and networks as well. Now, the second part of your question was about the mix of application types that you're faced with. You need a software package that can address each of those different application types. Studio 5000 Logix Designer is a multidiscipline software design environment that allows for that common foundation to be laid for your control systems. Now, this common foundation helps your design teams to share a common approach to the design itself. So what this really means is that you can go from designing a motion control system one day to a safety system the next day, all the way to a batch the following day. And have a common environment that keeps them from having to be trained on those specific disciplines. Now, sure, you're going to have some people that are better in some areas than the rest, but the foundation that they're building on and the approach to the software they're doing is the same. So Rockwell Automation's integrated architecture system is our portfolio of products and technologies that deliver real-time integrated control and information. So Miguel, I think that answers your first question.
Good to know. And can I still write modular code? It's important to my business to make changes or add new functionality. And it has to be easy to support.
Well, Miguel, the simple answer to that is yes, but let's dive into that a little bit. What you ask in your question is exactly why we are seeing the transition to more modular code designs today. Now, we not only see this in our hardware designs that the customers are doing, but we see this in their software designs too. Studio 5000 Logix Designer has multiple options for creating that modular code content that you're asking about. We have subroutines, we have add-on instructions, and our highest level container, the program. The modular coding design method allows for customers like yourself to not only make those changes to the design easier, but to understand what they are modifying and how that will affect their overall system design. It also allows for flexibility for their software design to grow with the advances they want to make in their application. Now, for the easy to support part of your question, let's discuss a complementary aspect of modular design, and that's context. Let's take an application of a steel slab caster. We can represent the system by the logical flow of the machine or the process itself. In other words, we describe it in how we're talking about it when we're talking about the project or the application with our peers. We use words like mold oscillator, hydraulic power unit, runout table. We can lay that out using the logical organizer within Logix Designer. We can lay that application out with the context necessary to describe that. And basically, we can arrange our modular design code and how we talk about the application. So in this example, I can see the context for each section of the machine, and then I can quickly narrow in on that part of the application that I'm concerned with. Example is I might have a question about how the drives are load sharing in the withdrawal straightener section. I might have a question, are the torches tracking the lead section of the bar correctly? I might also have a question about the runout tables and a hot metal detector actually detecting the bar. Again, with that context, I can quickly navigate to the area of the application that I'm interested in. And this makes it not only easy to locate that code, but exists for the life cycle of the project. Now think about that for a minute. With good modular design, with that context, it makes it not only easy to maintain, but also easy to duplicate for future expansion. So as you design for your connected enterprise, use Studio 5000 Logix Designer to build it upon a foundation that is modular, scalable, and sets you up for the future. Now, Miguel, I think you can see that we have options in each of those areas.
So that takes care of my scalability and modularity needs. Next on my list is collaboration. My experience tells me that collaboration among our engineers is important for a project's profitability. To be honest, all the parts of our design and build process work just fine, but when we put them all together, sometimes we trip over each other, literally, especially during commissioning. We could really benefit from better collaboration tools.
Well, Miguel, first off, I appreciate these questions. They line up very well with what we're seeing today. Now let's revert back to what Mike showed us earlier and how we took that workflow and dove into understanding how the customer uses the product in the design and build process itself. Now you touched on two areas that are important for maximizing that profitability. During the design, test, validate, and build, and also during commissioning. With each of these, there are areas where people need to collaborate, so let's frame that up with some real use cases. Commissioning. During commissioning, your team could be in the same control room, needing to be online with the same controller, needing to make changes at the same time in their specific areas. So you need to have the ability to quickly incorporate each of the team members' changes into the overall project. It could be from making those online changes that I'm sure many of us know about inside this room, or from importing content from a library to address a change maybe at a different level. Now, because Logix Designer has a multi-user online capability, they can do all that. Your team members can be online with the same controller, simultaneously making changes in their specific areas so their efforts come together more quickly and efficiently. Now, this particular workflow during commissioning suggests that they are in pretty close proximity, as we can see here. Not always, but typically. So what I would like to do now is explain a scenario where our design team is divided up across geography. It could be a few miles away or a few cubes away in the same office, or as we'll talk about here, across the globe. We're going to take the globe for this discussion because we see more and more work being divided up across geographies. And really, why not? The sun is always up somewhere. So here's our team divided up across the world. I have a lead engineer in America with 2 members that are remote. Each has their area of expertise that they will be adding to the overall project itself. The lead engineer will work on his or her part for the day. It could be setting up integration plans. It could be adding relevant code or even setting standards for the other team members to use. At the end of his or her day, the code is distributed to the other team members. Their day ends. The other team members, it's just beginning. Now, the sun is down where the lead engineer lives, but the project is still in motion. Each of the team members works on their assigned areas of the project that was delivered to them by the lead engineer. So maybe one is working on a safety aspect of the project, perhaps another one on a driver and motion control part of the project. At the end of their day, they send their efforts back to the lead engineer. The lead engineer starts the day with the task to evaluate what each team member has done and integrate their engineering efforts into a resulting master project file. The lead engineer uses Logix Designer's new compare and merge capability, and this allows him to identify each team member's efforts against the master copy that he distributed them the previous day. He then basically checks the box on the selections from their files that allow him to merge each of their efforts together. Here we see the safety code being brought in. Here we see the drive control code being brought in. And then we're bringing the lead engineer's efforts forward from the previous day. He then saves this newly master copy of the ACD file. And then from there, the lead engineer continues working on his part of the project and then redistributes that the following day. Now, this allows each engineer to see exactly what the other is doing, keeping them abreast of and up to date on the latest copy of the code. So whether you're in the same building or across the globe, Studio 5000 Logix Designer allows for a productive and a collaborative design environment, building your connected enterprise. Now, I think that sums it up for Miguel, and that leaves Julian.
I run my family's small OEM business. This is an exciting time for us because we're developing our next generation scalable machine. So we need an operator panel that'll be the face of our equipment, a symbol of our brand image. We want it to look good, be intuitive, and work for the different sizes of machines we sell. Can you help with that?
Hi, I'm Mark Hobbs. I can definitely help with that. In fact, we're introducing our newest operator interface products here this week. This is the new PanelView 5000 family of operator terminals. They're available in screen sizes from 7 inches all the way through to 19 inches. All of the terminals have high-resolution color displays, including new widescreen format options. As you can see, the terminal has a small footprint and sleek modern design that will look great on your machine. And mounting it in your panel has never been easier. Let's talk about the graphics capability of the product. The terminal uses scalable vector graphics technology, allowing you to create a single project and run it on any size terminal without modification. Creating attractive, powerful screens for the terminal has never been easier. The product comes with an extensive library of scalable vector graphics available in the toolbox. These are great-looking graphics, but they're also smart graphics. They have animations and built-in behavior to make it easy to show the state of your machine. Appearance attributes, such as color, can be configured, allowing you to create the look to your screen that will work best for your operators and your applications. Julian, any other questions?
Unfortunately, our competition won't be too far behind. So we need an efficient way to design our operator interface to make the most of our investment. My engineers tell me that thinking about control and visualization together can help. Is that true?
Yes, it is true. When you use View Designer, our new configuration environment for PanelView 5000. View Designer is part of Studio 5000. It works great with Logix Designer, offering you some immediate benefits such as a common installation and common launch point to create and manage your projects. The software has been designed from the ground up with usability in mind and workflows that make it quick and efficient to design your projects. We've enhanced our integration with Logix to reduce the time it takes to create an integrated architecture system. And I'd like to show you a few examples of what we've done. I'll begin with alarming. As you know, alarms can now be configured in the controller for faster detection and more accurate timestamps. Why would you want to duplicate this alarm configuration in your HMI panel? Well, you don't have to. The terminal automatically shows the alarms simply by connecting to the controller. There's nothing else you have to do. We have an alarm icon built into the system banner. It indicates when an alarm condition is present. And pressing that icon automatically takes you to a new control that we have, the alarm summary control. It allows you to view and interact with the alarms. The great news is that both the system banner and the alarm summary control are pre-built controls provided for you in the View Designer software with no configuration required on your part. View Designer also lets you create reusable screens to save implementation time and help enforce standardization. These screens can also be directly tied to a Logix data type so that all the information the screen needs can be passed into it at runtime with a single tag reference. Here we have a tank details screen that we're reusing to show information for multiple tanks. When the operator wants to view the details for tank 1, tank's 1 information is passed into the screen from the controller. When the operator wants to view the information for tank 2, tank 2's information is passed in, and so on for all the tanks that you want to view. Now, View Designer makes this setup really, really easy. First, you create or select the screen that you want to reuse. Next, you create a screen property and associate that property with a Logix data type. Elements on the screen are then bound to members of the Logix data type, such as the tank level. In the navigation menu, you create links or shortcuts to the base screen for each tank that you want to view on the terminal. And lastly, when you open a shortcut, your screen property appears in the property grid, allowing you to choose the specific instance of the Logix data type to pass into the screen for this shortcut. We've also simplified navigation. To do this, we include a navigation button on each terminal just below the display area. When that button is pressed, a menu appears on the terminal containing all the screens within the project for easy navigation. The navigation menu is built automatically on the terminal based on the layout of the navigation menu in View Designer. Now think about the savings this can provide. Now you don't have to create rows of navigation buttons on each screen, and the space is now freed up for more important application content. I have time for one more example, so I'd like to show you an innovative solution that we came up with to provide high-speed button control over Ethernet. This is ideal for jogging applications or any application that requires high-speed communications. When an operator presses and holds a jog button on the HMI, we write to the controller and initiate a jog operation in less than 100 milliseconds. When the operator releases the button, the jog operation stops, also in less than 100 milliseconds. Now, this capability took some real integration between our products to accomplish. In View Designer, there's a new jog command. It writes to a new input instruction, now available in Logix Designer. And to provide the high-speed deterministic communications, the terminal actually sits in the controller I/O tree and communicates over a class 1 connection, similar to I/O. Now, I hope these examples show you that Julian's engineers are correct. By thinking of control and visualization together, it can truly help you. Thank you, and now back to Mike.
Thanks. Thanks, Mark. Thanks, guys. Great job. I mean, those are some great examples of how Studio 5000 can help us all be more productive and achieve the connected enterprise. You know, we thoroughly hope you've enjoyed this session here today, and we encourage you to attend many, if not all, the sessions offered this week on Studio 5000. So once again, thank you all for your time, and have a great week at TechEd.